All right, so number 32. The question is, how far the ship traveled from A to D. So they want you to find this distance here. All right, no problem. Let me show you how I'm going to do that. So to answer this question, what I did is first, I visualized this as one big right triangle. And I'll just go ahead and draw that separately for you right over here, right? So that's just one big right triangle. And what I'm going to do is I'm just going to use that big right triangle to find the missing side AC. So now to find AC, you're going to have to use a trig ratio. Remember your trig ratio, SOHCAHTOA. So the one to use here would be tangent. So you would say the tan of 7 degrees is equal to the opposite side over the adjacent side AC. So if you put this over 1 and you cross multiply, you will come to find that AC is equal to 125 divided by the tan of 7. So what is that equal to approximately? Well, let's get our handy dandy calculator. 125 divided by the tan of 7 is approximately 1018.0433. All right, so then that gives me the side, let's just leave this on the side over here. So then that just gives me the side AC. So I know, now I know that this whole side here, AC, okay, this whole thing is 1018.0433. Great. All right, next, let's find this little side over here, the side DC. Let's go ahead and find that. So now in order to find that, I need you to just see that there's like a right triangle right over here. Do you see it? It's the right triangle DBC. Okay, so we got a right triangle DBC. And then that's just like my little rendition of it. DBC. All right, so we want DC. We know this angle is 16 degrees, and we know this is 125. So in order to find the missing side DC, I'm going to have to use the tangent again. So then it's going to be the tan of 16 degrees is equal to the opposite side over the adjacent side, which is DC. So DC will be equal to 125 divided by the tangent of 16 degrees. What is that equal to? Well, that I don't know, and I need my calculator to get it. So let's get a calculator, and let's get to working on that. Let's just move that out of the way. All right, so then it's going to be the 125 divided by the tangent of 16 degrees. So then that is approximately 435.9268. So let's go ahead and write that wherever I have room, I suppose. I have some room here. So that's 435.9268 for the side DC. And then the side AC, we had found it was 1018.0433. All right, cool. So if you want the side AD, then all we have to do is subtract 435.9268 from the whole thing, which was 1018.0433, and we'll get our answer. So let's just go ahead and do that right now. So it's going to be 1018.0433 subtract 435.9268, and it's approximately 582.1165. Are we told to round to a particular place? It says yes, round to the nearest foot. So to the nearest foot, the answer will be 582. So 582 is the answer. After subtracting, that's what we get. All right, so number 33, we have a triangle ABC. They're only giving us the y coordinate of A, so I can't plot A. They're giving me the coordinates of B. There are -3, -1, so B is right over here. I'm given the coordinates of C as -1, -4, so C is here. Determine and state a value of x that would make triangle ABC a right triangle. Justify why triangle ABC is a right triangle. Okay, so now what do I know about point A? Well, I know point A has a y coordinate of 3. So point A, it must be somewhere along this line because it has a y coordinate of 3, right? Now, it has to be along this line in such a way that A, B, and C form a right triangle. So for example, I'll tell you where it can't be. So for example, it cannot be over here, let's say. Because if you put point A right there, and this is just, just showing you an example of something that will not work. If you put point A right there, you will not get a right triangle. That is not a right triangle. Now, how do I know that's not a right triangle? I know that's not a right triangle because I don't have a 90-degree angle, and I know that because the slopes of the lines of neither pair of these lines are negative reciprocals. That's how I know. So that right there gives you a hint as to what I need to do. Now, in order to determine point A, I have to look at the slope of BC. So the slope of BC is down 1, 2, 3 over 2. So the slope of BC is down 3 over 2. So if I'm going to make B my right angle, that automatically means that the slope of BA must be 2 over 3. Now, how did I get that? Well, these have to be negative reciprocals of each other because I need a 90-degree angle to form a right triangle. I need a 90-degree angle, and the only way to get a 90-degree angle is if I have perpendicular lines. And I know that the slopes of perpendicular lines are negative reciprocals of each other. So let's go to point B, and let's follow the slope I got. It's going to be up 2 over 3, up 2 over 3, and then you can see right here is where I must have my point A. Okay, so that must be my point A. And then this would be the 90-degree angle, and then that's a right triangle. All right, so our response will be, one way to write it could be this way. The coordinates of A are 3, 3, because these coordinates will cause BA to have a slope of 2 over 3, which is the negative reciprocal of -3 over 2. Okay, so we know that in order for us to have a right triangle, we need to have a right angle, and the only types of lines that cause right angles are perpendicular lines, and we know that perpendicular lines have slopes which are negative reciprocals of each other. All right, so number 34, this is a transformations and rigid motions type of question. So what are they giving us in the diagram? So they're giving us two triangles. What they are saying is that there's another triangle which is not pictured here that is the result of a translation along the line L. Okay, so there's some other triangle that's not pictured here. And that triangle that's not pictured here is the result of a translation along this line, right? That's what it's saying. So that triangle that's not pictured here is the result of a translation of triangle DEF along the line L, right? So we know it's not, it's not translating this way or that way, right? It's translating along line L. That's the important piece, right? It says so right here. It's translating along line L. Now, they're saying, look, it's translated in such a way that point D will map onto point A. So point D will map onto point A. So if that were to happen, where would you end up with F prime? Where would F prime end up? Well, F prime would end up where C is. Now, why? So that's what we need to explain. So let's go ahead and write that down. It says, since the translation is a rigid motion, we know that the lengths of the original image are preserved. If D maps onto A, then F must map onto C because AC is congruent to DF. All right, second question. It's asking us what would happen if we reflected D prime, E prime, F prime in such a way that E prime mapped onto B. Would the triangles be congruent to each other? And that's a very obvious answer if you know your definitions for rigid motions. I said yes because a reflection is a rigid motion which preserves size. If all you're doing is reflecting it, then of course, yeah, you're going to get an image that's congruent to the original one. All right, number 35. So we got ourselves a proof here, and we want to go ahead and prove that the parallelogram ABCD is a rhombus. So if you recall, a rhombus is a parallelogram in which all the sides are congruent. So what I'm going to try to show here is that all of the sides are congruent, therefore ABCD is a rhombus. So this is how I go about it. I'm given all this stuff here. I'm given that we have a parallelogram. I'm given a pair of perpendicular lines, BE and CED, and then another pair of perpendicular lines, DF and BFC. And I'm given that CE is congruent to CF. To help with this proof, what I like to do is separate the triangles. Believe me, it is a helpful thing to do that. So this is FCD. Whenever I have overlapping triangles, I like to separate them because it helps to see things that you wouldn't see if you didn't separate them. So look here, right? We were told that CE is congruent to CF. So far right there, I got a pair of sides that are congruent. And then that was given, and I already put that there in the given. And then check this out. You see this triangle C over here? This one's being shared by both of the triangles. So then I know that this angle BCE is congruent to angle FCD. And then I wrote that right here, right? And then that's because of the reflexive property. Now remember, they told you that you had a pair of perpendicular lines here. They told you that line DF is perpendicular to line BFC, so we know we have a 90-degree angle there. So I'm going to go ahead and label that here as well. And then we also know that these lines are parallel as well, BE and CED, so I have another 90-degree angle here. So then let's go ahead and put that. So I'm going to go ahead here and say, some people say this in two statements, I just say it in one. I'm just going to go ahead and say angle DFC is congruent to angle, what's that, BEC, to angle BFC, and then I'm just going to say they are both 90 degrees. And then now you can actually say that the triangles, you can say triangle, what are the names of those triangles? So you can say triangle BCE is congruent to triangle DCF, to triangle DCF. And then now, why are those triangles congruent? Well, those triangles are congruent because of the angle side angle postulate. So angle side angle congruent to angle side angle. Now, since we know that those triangles are congruent, okay, we've already proved that they are congruent. If those triangles are congruent, then we actually can go ahead and say that side CD is congruent to side BC, right? We can say these sides are congruent to each other because the triangles are congruent to each other. And if the triangles are congruent to each other, then the corresponding parts of the congruent triangles are congruent to each other. That's CPCTC. So let's go ahead and say that. So we're going to say CD is congruent to BC. It's congruent to BC, and then that's because of CPCTC. Now, why is this a rhombus, right? It goes back to that. Well, now we know it's a rhombus for sure because it's a parallelogram with consecutive sides that are congruent. And if these consecutive sides are congruent, then that means these are congruent. And then it's automatically a rhombus because all sides are congruent. So then I'm going to say ABCD is a rhombus. And then the reason for that is consecutive sides BC and CD are congruent. Okay, and then that makes it a rhombus. All right, so number 36, we have a weight, density, and volume type of question. So just remember for these questions that weight is equal to density times the volume. All right, so what's the deal? He wants to make 100 candles, and we want to know what will be the volume of those 100 candles. All right, so what do we know then? Well, we know that each mold will have a height of 8 inches. So we know that the height is equal to 8. And the diameter is 3 inches, so then that means the radius will be equal to 1.5. All right, so then let's take a look at this candle. So the candle, as you can see, it is in the shape of a cone, right? So this is your candle here. So what's the volume of a cone? Well, the volume of a cone is 1/3 times the area of the base times the height. But keep in mind that the area of the base is pi r squared because the base is a circle. So the formula is V equals 1/3 pi r squared times the height. That's what we get when we substitute for the area of the base. All right, so I think we have enough information to plug in and find the volume of 100 candles. Because what we'll do is we'll find the volume of one candle and then just multiply by 100. So we get V equals 1/3 pi. The radius is 1.5 squared, and then times the height, which is 8. So this is the volume of one candle, right? So let's put that in a calculator. So we can put it into the calculator this way, and then that's the volume of one candle. I guess I could just write that down. It might come in handy later. I don't know. It's 18.8496. So what's the volume of 100 of those candles? So let's just hit times 100. And they want us to round it to the nearest cubic inch, so that's the nearest whole number. So the volume of 100 of them is 1885 after you round it off. All right, so that's the volume of 100 candles. All right, so for the next part, Walter goes to a hobby store to buy wax for his candles. The wax costs 10 cents per ounce. If the weight of the wax is 0.52 ounces per cubic inch, how much will it cost Walter to buy wax for 100 candles? Okay, so I need to figure out what's that weight going to be for 100 candles. So if we go back, remember that formula I wrote at the very beginning? Weight equals density times volume. So we know the volume for 100 candles is roughly 1885. So we know that. And we know that the density, or like, that's like the weight of the material that's going into the candles. We know that that density is 0.52 ounces per cubic inch. So all I need to do to get that total weight is I need to multiply 1885 by 0.52, and that will give me the answer. So I have a volume of 1885 cubic inches, and I'm going to just go ahead and multiply that by 0.52 ounces per cubic inch. So what's going to cancel out here is the cubic inches, and I'll just be left with ounces, which tells me that total weight. So then what is 1885 times 0.52? Let's get our calculator to do that. So 1885 times 0.52, I get 980.2. Okay, so now the wax costs the wax costs um 0.10 cents per ounce. So then to get that total cost, I have to multiply 0.10 by 980.2. And then I'm gonna get my answer that way. So that's gonna be 98.02. All right, so let me write some of this stuff down. So 980.2, that is like the total weight, and then I multiplied that by 0.10 to get the costs for that. So then that came out to 98.02. So that's the answer for this part. Okay, the next question says if Walter spent a total of 37.83 for the molds and he charges 1.95 for each candle, what is his profit after selling 100 candles? So think through this, right? What's his total costs? What are his costs? So what are some of the things that he spends money on? Well, we just wrote that down, right? He spent 98.02 on the wax. And then it says here that now he's going to buy the molds for 37.83. So what does that come out to? Are 135.85. Okay, those are the costs. That's not the answer. If you want to know how much money he made, we'll take how much he took in, right? So that's like his revenue. How much money did he take in? So his revenue is 1.95 per candle. So he sold 100 of those. So then what's 1.95 times 100? Well, that's 195, right? He took in 195, but he spent 135.85. So then revenue subtract your costs, that will give you your profit. So what's 195? 195 minus 135.85. That comes out to 59.15. So his profit is 59.15. That is the answer. All right, hope this helps. Take care.